Okay, and so we are broadcasting on YouTube. And let me share this as well on our social media. We're going to start letting people in the room. Welcome to those who are just joining us. We'll be starting in just a minute here. We are very excited to bring this opportunity through a collaboration between LXAI and the HPC Latin American cross-continental collaboration as well for the Americas. And if you just give us a moment, we will begin with introductions, allow some people to join in from our meeting, from the waiting room, and then we will get started. Okay, so let's go ahead and get started. We are 1 minute after the hour, and I know more people will be joining us little by little, but it would be great to start with introductions. So thank you everyone for joining us today. My name is Laura Montoya. I'm one of the founders for the LXAI organization and programs. We're very excited to be with you here today, in particular for this session on behalf of our LXAI Supercomputer network program. So for this webinar, we are very excited to have a guest speaker joining us today. She will be discussing a presentation based on her background and experience, but also some very exciting programs that she is working with, including the Americas HPC Collaboration, which includes opportunities for cross-continental partnerships, as well as her work with the Department of Energy and the Oak Ridge National Laboratory. So our speaker today is Veronica. Veronica Melise Vergara is originally from Quito, Ecuador. Veronica earned a bachelor's in mathematics and physics at Reed College and a master's in computational science at Florida State University. She has over a decade of experience in high-performance computing field and is currently the group leader of the System Acceptance and User Environment Group at the Oak Ridge Leadership Computing Facility. In addition to providing assistance to OLCF users, Veronica is part of the systems testing team, leading the acceptance for Summit and leading acceptance for Frontier, the ORNL's exascale supercomputer. Her research interests include high-performance computing, large-scale system testing, and performance evaluation and optimization of scientific applications. Veronica is a member of both IEEE and ACM, and serves on the ACM SIG HPC Executive Committee and the SC steering team. Thank you very much, Veronica, for joining us today and for sharing insights and opportunities through your organizations. Please take it away.
Thank you so much, Laura, for the invitation. It's great to be here today. I'm going to share my slides, but I was really excited to hear more about the LXAI organization, and Laura and I chatted a little bit on like what efforts are sort of intersecting both organizations. So I thought it would be a nice way that we could collaborate by having co-hosting organizations, co-hosting webinars. So I'm excited to be here today, and I hope that we can host LXAI in the future for America's HPC Collaboration as well. But let's see, share screen mode. And hopefully you can see my slides okay.
Yes, we can. Thank you.
All right, thank you. So just to give a little background on myself, because I mean, a lot of the times people that work in high performance computing, they have very different career paths. So I like to always give an overview on like how I ended up in high performance computing, because that's not what, when I was a little kid, that's not what I thought. Like, oh, I'm gonna grow up to be a high performance computing engineer. So I'm originally from Quito, Ecuador, as Laura mentioned. I moved to the States in 2005. Here is me with my husband. He's from Ethiopia, Michael. And during pandemic, we adopted Ziggy, our Labrador rescue mix. And then a year later, we adopted Zoe. So now we're a family of 4. But we've lived in East Tennessee I've lived in East Tennessee for about 9 years now. But before I moved here, as Laura mentioned, I got a bachelor's in arts in mathematics and physics from Reed College. This is more liberal arts college in Portland, Oregon. And I came there as exchange student because I wanted to see what other cultures were out there. And then after I moved to the US for an exchange program, I decided to stay, graduated from Reed. And since I like computers and I like science, but I needed a job, and it was 2008. I looked for any jobs that was like programming related or use computers in some way. And I became a QA analyst at WebMD, like WebMD.com. Their headquarters is in Portland, and they had all kinds of like computer related jobs. So I became a QA analyst for 1 year, but I really miss science, because when I was at Reed, I had the chance to do a bachelor's thesis that used scientific computing to simulate something that I wanted to simulate. And at the time, I just did a simulation on snowflakes because I wanted to see how that worked. And it was, I did it mostly because, well, yes, it was a requirement, but I like computers and I like physics. And I felt like that was a nice space. But once I started working professionally as a QA analyst, I realized that I still missed the science aspect, even though it was a good job and we had lots of great colleagues and things to do. I still missed the science aspect. So I went back to grad school and I found a program at Florida State University that actually, because I wasn't a computer scientist or a physicist, so I was sort of in between, and I found this program at Florida State that was a computational science program that was outside computer science department, and it focused on scientific computing. And I got my master's there, and while I was working there, I actually heard about the supercomputing conference that I'm heavily involved now. And the supercomputing conference happens in the US every year. It's one of the largest high-performance computing events that happens in our field. And I became a student volunteer there. And when I still I finished my computational science master, I was still planning to go and find a programming job because I didn't think at the time that there were careers in scientific computing that I could pursue and make a living out of. So I went to that conference and I realized that that was not true. Like there's a lot of high performance computing jobs. We have universities that need high performance computing people. We have companies like Intel, the HPEs, the Googles of the world, everybody that is in industry normally would need somebody that has skills in different layers of high performance computing. So I ended up working at Purdue University Rosen Center for Advanced Computing, and that's in Northern Indiana. And I worked there for 3 years as a scientific applications analyst, and it was a really rewarding job. Like we had the chance to work with users directly, and we had the chance to solve problems every day. Like every day would be a different problem to solve. And because I stayed involved in the supercomputing conference, I ended up moving here to Oak Ridge because I met through networking and through attending the conference and helping with various student cluster competition activities. I met my current boss and I moved here to Oak Ridge as a high performance computing engineer. And that was back in 2014. And since then, I've become a group leader for the system acceptance and user environment group. And we focus primarily on like the pre-production stages of the system. So whenever Summit or Frontier were just being deployed, our team like runs tests and make sure that you can actually run the workloads that our users will run on the system before it's actually put into production. So we do a lot of the software environment deployment, and we run tests, and we try to understand the performance of the system or any issues that the system may have before the system gets to users' hands. So that's sort of a little bit of like my path to HPC and where I am today. But to tell a little bit about why you're here, so we have, since I've been involved in the supercomputing conference, I met several folks a few years back from different institutions, and being from Ecuador, I wanted to learn what other people that were from Latin America were doing in HPC. So way back when Carlos Jaime Barrios had a presentation about the Carla conference at the time. I think it was above a C15. And he mentioned that they had done a Birds of a Feather session at Supercomputing Conference and also at ISC, which is happens every summer in Europe, usually in Germany, and it's another large high performance computing event. So we decided to team up. So we had two folks you see in the picture here. To the right is Benjamin Hernandez, Silvio Risi, and then to my left, well, in the picture in the left, it's Carlos and Philippe Nabo from Brazil. So we had representation from Mexico, Argentina, Colombia, and Brazil, and Ecuador with me. And we decided to kind of band together and make the Americas Collaboration Organization sort of like an official effort. And we started with Birds of a Feather session that we put together in 2019 after, officially with the name Americas HPC Collaboration. But then we've had events, virtual events throughout the year, because obviously 2020 pandemic came. But we had virtual events at ISC, at SC, and the Carla conference. And we have a Slack channel that we try to keep in touch with people and try to understand what others are doing in HPC in the region. But the main reason that we wanted to have the organization and have a place that we can communicate is to build community and understand what are some of the blockers and what are some of the barriers that maybe keep the information from disseminating. There's a lot of high performance computing research that's going on in Latin America, but not necessarily translates to what you see in papers or what you see in projects here in US and Europe. So Carlos actually has another collaboration with Europe and Latin America. So we were trying to understand more how we can help, and me and Silvio, and at the time Benjamin, but since then Benjamin has moved to NVIDIA. So we have folks in several places, and not in the picture, Esteban Meneses is from the National High Technology Center in Costa Rica, Senat, and Jose Manuel Monsalve Diaz from Argonne. They are also part of the collaboration. Jose joined last year, and together we've been trying to figure out how are some ways where the research that's going on in Latin America could be scaled up to beyond the resources that are available in Latin America, because I think there's a lot of projects that are resource limited, and that's a gap we're trying to help narrow. Let's see. So the Americas HPC Collaboration focuses on online content to reach broad audiences. So we held webinars, and we try to keep in touch and come up with proposals that we can submit together. And we aim to highlight the research that is happening in Latin America and the Caribbean. We want to describe opportunities, because one of the things that from surveying students when we attended the Carla conference, we're made aware that we didn't have necessarily, it's not necessarily that people don't apply, they may not even know that the opportunity exists. So we try to describe opportunities and resources that are available to students, even if you are outside the US, to come to US, or if you are studying in the US and maybe a foreign national, what is available to you and what programs you can apply to. And same for faculty and researchers. There are avenues that still are possible, or maybe even some of the folks that are in the large data centers here go to do a knowledge exchange in your facilities abroad. So there's definitely opportunities, but the first step is to know that those exist. And then once we have those connections, we wanna try to figure out a way that we can form long-term collaborations rather than a single instance of an engagement. We wanna have a long-term collaboration that becomes fruitful and helps expand both sides, because we want it to be both helpful for the researcher or student abroad, but also helpful for the facilities here. And then we want to grow our online Slack community. So if you are interested in joining, that tiny URL should take you to our Slack community, and you'll be able to join, but also feel free to reach out. I can share my contact info later in the talk. But one thing that I wanted to highlight is some of the activities that we did in 2021 and 2022. We wanted to showcase what kind of research is happening that uses HPC resources in Latin America. So we had invited speakers from different areas, and we also wanted to highlight the student opportunities. So as I have been involved very heavily in the supercomputing conference, SC conference series, I wanted others to know that is a possibility. And this SC conference series actually has student travel programs for international and US domestic students And for Carla, just make awareness that the conference exists and it rotates in different parts of Latin America, so that if you happen to be in that country at the time, you are aware that it's happening. We also had an introduction to the Argonne training program on extreme scale computing that Ray Law gave in 2021. And that program, it covers ABCs of HPC, is a very good program, and it's also open to students that are studying in many areas of the world, and you can also get travel funding if you are accepted into the program, you can also get travel funding. So there were some of the areas that we wanted to touch base. And then in 2022, we wanted to highlight research that had happened in the facilities and what kind of collaborations people could get involved. So like if somebody in the facilities here is studying a particular topic that you're also studying, participating in the webinar, making that connection so that we can hopefully build upon those connections. And every year we try to have like, here are the opportunities that are available, these are the deadlines, and these are the different programs that you could apply and by when, and which ones are restricted or not restricted. Let's see. And yes, I saw a question. I can put the invite in the chat in a second. So one of the other things that we did as part of the collaboration activities, we had BOF at Carla 2023, but we also held a workshop. So instead of having a gathering of minds to build community, we held a workshop at Carla 2022 that accepted papers from the region and anybody that wanted to apply, but we focused primarily on the region where Carla 22 was held. And then the next year we had a BOF because actually 3 of the people that are organizing America's HPC Collaboration were in the organizing committee of the Carla conference, so there was just too much to do. So in 2023, we didn't have as many events specifically under the collaboration, but we had a lot of effort as part of the committee for program committee and general chairs for the Carla 2023. Like Carlos, Jose, Esteban, and Silvio were all involved in Carla 2023. But if you are interested in helping plan, or if you have research that you want to showcase, and obviously this is not limited as AI has become more and more a workload that our facilities support. If you are working in AI, we also want to hear from you. It's a collaboration focused on HPC, but AI is definitely very much in the picture. So if you're interested in helping with website content or presenting a webinar to tell others what you're working on, or even like organizing activities, please join our Slack channel, and I'll post the Slack channel in the Zoom, but I can also flash it here real quick just so that you have it. Or it's just tinyurl.com, Americas on lowercase, Americas HPC uppercase collaboration -- Slack lowercase. And let's see. So that's on the Americas HPC Collaboration side, but I also wanted to share a couple of success stories. At least I consider them success stories. That in Carla, the Carla conference has hosted Latin American Women in HPC workshops since Carla 2018. But then in Carla 2019, I was able to go to Carla in Costa Rica and had a chance to work with several women that organized the workshop. And then we submitted a proposal for a chapter. So there's a Women in HPC in Latin America chapter. So that virtual chapter exists today, and every year at Carla we organize. Sometimes the organization rotates between the location because we want to host students and women that are local to the host city, but we also organize virtual events for our chapter. So if you're interested in that, let me know. We also have a channel in our America's HPC Collaboration Slack about Women in HPC Latin America chapter. But that I consider a success story because had we not had these connections with the conference and with members of American HPC Collaboration, I likely would have not been able to know that the efforts existed, and being able to contribute to it by helping put together a chapter was definitely something that I think is worth highlighting, and is something that we can grow upon, and we can start having more activities. But we also would love to hear from you and what kind of activities you'd be interested in, and what kind of activities you'd be interested in helping us organize as well. And another success story, and this was actually covered in the Birds of a Feather session that we had at SC23, the supercomputing conference that just happened last week. The Centro Nacional de Alta Tecnología in Costa Rica actually has a collaboration with the Argonne Leadership Computing Facility, which is one of the DOE facilities that I will tell you a little bit more about in the next few slides. But they partnered with 2 different projects. They're both visualization related. And this work was actually done in collaboration with Silvio Risi. So Johansson Villalobos and Christian Ax Burgos both had efforts that were going on as part of a project. They got a director, a smaller location in the ALCF systems to run the simulations, and they were able to get successful results from those. So now they have an ongoing collaboration with ALCF, which I think is sort of the goal, to be able to make the connections, introduce researchers to researchers here, and then enable them to use larger resources through the DOE resource programs. And another success story that I think was enabled by, but it also included several people from many areas of the Americas HPC Collaboration and outside Americas HPC Collaboration, was the creation of the SIG HPC Computing Continuum chapter. SIG HPC is a special interest group for high performance computing, part of the Association of Computing Machinery, ACM. So if you're part of ACM, you can also join directly SIG HPC, and you can now join the specific chapter, so SIG HPC Computing Continuum chapter. And originally, it was intended to be primarily like SIG HPC Latin America chapter and Latin American Caribbean chapter, but due to the specific topical and how ACM does their chapters, we try to be more inclusive for others that are interested in like supporting the efforts, but also want to care about specific things that Latin America cares about. So it's, rather than being regional, is now focused on a wider range of topics, but also centered around SIG HPC, around HPC and data analysis and science, and how that helps connect sort of like what we're doing with computing with real applications that impact real people. So that's sort of how it got started. But the members of the chapter are all part of Americas HPC Collaboration in some way, and we're hoping that we can do more activities through there as well, because as a chapter membership increases, hopefully we'll be able to do more activities and have a partnership, a close partnership with them. And if you're interested in learning more, sighpc-continuum.acm.org is where you can find more info and how to join. But also if you have questions, I'm happy to tell you a little bit more about that later as well. Let me see. Oh, thank you for posting the links. But then I mentioned earlier that some of the success stories had used the leadership computing facilities, and you may be wondering, what is a leadership computing facility? As Laura mentioned in the beginning, I work at the Department of Energy Leadership Computing Facility, and there's actually several computing user facilities. There's 2 that are leadership computing facilities, Argonne and Oak Ridge. And there's also the National Energy Research Scientific Computing Center, which focuses on capacity computing. But in general, the Department of Energy in the United States has been a leader in HPC for a while. They aim to provide the world's most powerful computational resources for open science. So that's one of the key things that sometimes people are not aware of, like the access to the resources is free and is open to open science. It is open to anyone in the world, despite being a United States-based organization. So the idea is to boost the United States competitiveness and also be able to attract research and be able to enable research from all over the world, because we want the best research. The end goal is to have the best research and the best science that we can do at large scale. And for that, we need everyone that has been doing research, regardless of where you are. So access is free. Those are the key takeaways, and is open to anybody in the world that has a scientific use case. But specifically, the 2 leadership communities that I mentioned, they're collaborative. So we have 2 centers, and we work together in several programs that you see listed here, like the allocation programs. But the goal is to provide an ecosystem that enables capability computing. And capability computing, what that means is that jobs that are as large scale as you can think of them, so we can solve the most challenging problems. In general, in both facilities, at OCF, if your jobs are larger than 20% of the machine, they qualify as a capability computing job. And the resources are actually administered in several tiers. So we have the first 2, Innovative and Novel Computational Impact and Theory and Experiment, the INSIGHT program, and the ASCAR Leadership Computing Challenge, ALCC program. those are large allocations and they're very competitive and they're decided at the DOE level. We contribute with reviews, computational readiness reviews, and scientific review panels, but the DOE is who decides who gets access through those, and they're typically 100x larger than what you could find in an HPC center at a campus or a laboratory, or even in industry. So you can get millions of hours on those machines through those programs. But in addition to that, there's other programs that I'll tell you a little bit more later that will allow you to sort of ramp up to one of those big allocations. Particularly to the Oak Ridge Leadership Computing Facility, we've delivered 7 systems since 2004. Frontier is system number 7, and it has an increased capability of over 80,000 from comparison to our Phoenix system in 2004. And large parts of the success of the facility and being able to deploy large-scale resources has been a partnership with both our users, but also our vendors. Like, we have been able to rapidly evolve the scientific applications that are being run on the systems. Like when we switch, for example, from running on Summit and Titan to running on Frontier, it has different architecture, it has different programming models, you have to use the machine differently. So our strong partnership with our users is what has allowed us to port the workloads from one system to the next. And we hope it continues to allow us as we move to the next system after Frontier. Frontier was deployed earlier this year to users, but it was installed late 2022 and 2022. So we had access to the system, and my team helped test it and make sure that whatever issues we found were reported to the vendor, addressed before we could put users, and we opened the system for allocations in early 2023. But to give you a little bit more detail about what Frontier is a Cray EX system. It has 74 cabinets with 9,408 compute nodes. Each compute node has 1 CPU and 4 GPUs, but the AMD MI250X GPU actually, it's 2 GPUs together. There's really 2 graphic compute dies that are exposed to the user as 2 separate GPUs, but it's 1 GPU that has 2 cards. It's also connected by a slingshot 11. And here in the right-hand side, you see sort of a graphical picture of what the node looks like. So we have the 64 cores and the 4 GPUs that have 2 GCDs. In this case, we name them GPUs because that's what the user will see, or how a user would think of them, and how they're connected in between each other and also out to the network. Frontier has a parallel file system that has 679 petabytes of usable space, is Lustre-based, and that's where users will run. That's a scratch space, not to leave your data all the time there, but that's what people use to run their active campaigns. And then the software stack includes the HPE Cray programming environment and the AMD ROCm software stack. So to actually use the machine, you have to have code that is able to use HIP or uses OpenMP and offloading to AMD GPU or another similar framework that will allow you to offload work to the GPUs. And that's one of the key things that we want to emphasize whenever somebody is applying for time on the machine, is to be able to demonstrate that you will actually be able to take advantage of the full architecture. If you have a code that doesn't use the GPUs at all, obviously that's not something that will make use of the node, efficient use of the node, because all the performance, majority of the performance of the system lies on the GPU. So we want to have codes that are already ported and can take full advantage of the GPUs. But then, as I mentioned earlier, like those allocations that are available inside an ALCC are decided at the DOE level. They give you millions of hours potentially, but how do you get there? If you're just starting out, or if you're moving from a campus computer, supercomputer, to maybe a larger supercomputer, or if you don't have necessarily GPU-enabled codes yet, excuse me. So one of the avenues that we've set up at OSCF is the Pathways to Supercomputing initiative. And there's actually 3 parts of the initiative. We have the HPC crash course that we normally hold virtual crash course that covers HPC, and anybody in the world is able to join. We will send out accounts. We'll set up a Zoom session so we can attend the lectures, and we set up accounts for folks. There are some restrictions because we are a DOE facility, but for the most part, the crash course is available to anybody that wants to sign up. And then we have the Pathways to Computing internship program that is actually an internship program available for domestic students. You could be a foreign national studying in the US, but you must be in the US because you have to be eligible for work. But it is an undergraduate 10-week internship at ORNL that focuses on computing areas. And then the Pathways to Supercomputing initiative, that is the main sort of on-ramp to the bigger programs that we recently started. So this is assist researchers and institutions that are currently underrepresented in HPC. So our goal was to understand like what is keeping us from receiving applications from underrepresented regions and institutions in HPC, including MSIs and HSIs in the US, but also underserved regions or regions that we know HPC is happening, but we're not getting necessarily applications from. And one of the areas that we're trying to do is also communicate what are we looking for and what are avenues available, but also trying to provide a way that you can move, because moving from a campus cluster to frontier, that's a big gap. But with this program, what we're trying to do is pair you up with a mentor so that you can be like, oh, I have a code. I know I can run it in a GPU that I have in my lab or something, but I don't know if I can scale up. And once you know you can scale up, maybe you'll think of a bigger problem, or you'll think of a problem you hadn't thought about before. So what we try to do with this program is, if you are accepted into the program, you get a smaller allocation, smaller than the director discretionary, but it will help you to get the data that you need to understand if your code actually could scale beyond what you think of, or if you think of a new problem that actually will allow you to gather the data that you need to apply for one of the more competitive allocation programs. So it's sort of like an on-ramp startup allocation that will help you eventually apply for a director discretionary allocation that is decided locally, or one of the DOE programs that's decided at the DOE level. But you definitely have to have like all the information that is required at each point. So this is Pathways to Supercomputing initiative, so sort of gives you a startup mechanism to get there, and we'll pair you with a mentor here at OCF that will help you run on the machine and figure out if your use case actually fits the machine. Because Summit and Frontier are sort of unique. Summit has Power 9 and Frontier has AMD GPUs. It is not necessarily all workloads can run on the system out of the box, so it has, sometimes you need to have a little bit of help before that can work. And depending on what your particular workload is, that's how we would determine whether you could be a good candidate for Pathways to Supercomputing initiative. But if you're interested, the first step would be to submit an interest form, and then somebody from OCF will follow up with you on how you can, or whether your use case meets the facility requirements, and how we can proceed from there. And let me just go back real quick. So the Pathways to Supercomputing page is here, ocf.royal.gov, Pathways to Supercomputing. And this will take you to the forum, both for if you're interested in participating in the crash course, or you just want to learn more about it, or the internship. There's also information there too. Then just to like highlight, we had already 3 institutions. They were all in the US that have successfully applied and got allocations through the Pathways to Supercomputing initiative. And currently we also have one in the pipeline from Colombia that I'm very excited about, that we're working through the final details to get that institution added to the pool. But this program is helping us an on-ramp, so that once you have access to the system, you maybe tweak your workloads a little bit differently, or think of other things you can do to solve your problem or expand your research. And hopefully that will allow you to apply to this director discretionary and eventually an inside or ALCC program. And then just as a recap, these are the programs that are currently available. And obviously, since I'm from Oak Ridge National Lab, I talked a lot about ORNL, but there are similar programs for director discretionary at Argonne National Lab, as I showed the 2 examples of successful collaborations with Costa Rica. But we also have the general call. So right now the ALCC allocation program call is open, but pre-proposals were due already, but the call is open and usually closes in February, and the install allocation program will open next year, and then you can apply to that one as well. And with that, I saw chat messages, but I think most people were looking for the links, but I am happy to answer any questions you may have.
Thank you so much, Veronica. That was a really great introduction to all these amazing initiatives that you are involved with and those that are available as well to our community through the companies that you work with. So yes, we can have questions posted either in the chat, or for those that are in our Zoom call, you are also able to post or unmute yourself if you'd like to ask directly any questions. And we're also monitoring the live stream on YouTube. So if anyone watching us on YouTube would like to post a question, please feel free to do so, and we will relay that to our speaker. Okay, and maybe to get us started, can you give us an example of a type of project that would be a really good fit? Because I know many of our users within our artificial intelligence network are looking for access to computational power. Some of them are maybe working on projects that are like a smaller scale to begin with, as they're just testing or figuring out how to develop a model or to scale a model. What would be like the baseline minimum requirements for some of these programs and opportunities that you mentioned? Like what level would they have to be at? What would they have to show as far as the amount of data or kind of proof of concept in order to potentially be approved for receiving an allocation in one of these different systems?
Yeah, so that's a good question, and we've seen more and more AI project proposals come in, and that's an area that a lot of the AI workloads that we've seen so far, maybe they don't need to scale like wide, so they don't need a job that is 9,000 nodes wide, but they need lots of smaller, longer jobs, and so many jobs that computationally is still as computationally intensive as a big simulation that is using 9,000 nodes. So we do have those workloads, and those workloads also fit into the criteria that we've described for all our programs. We are sort of trying to, because we are a leadership computing facility, and like I mentioned, we try to target for the big programs, jobs that are beyond 20% of the machine. So on Frontier and Summit, that's thousands of nodes. We have sort of a special bucket where we put the AI projects. And on Summit, currently, Summit was put into production in 2018, and it was actually going to be decommissioned this year. But because it's such a good machine and it's so stable, we extended it one more year, and we have a new program that invited workloads that will be provided, that those kind of workloads that are more maybe not the standard traditional workloads for modeling and simulation that are wide jobs, but we'll have jobs that will be more AI focused. And on Summit, we have a queue that actually has fewer nodes, but it has long running jobs. So that is more friendly for AI workloads that we've seen so far. But there isn't like you must be this tall to ride kind of criteria. Like it depends a lot on like what is the scientific merit of the project. Like if you have a scientific use case that is like solid and your science is good, like at least from what we've seen, the barrier is more like what your resource you have. You may be thinking of a project that, I'm going to analyze this many sequences a day, but if you had more, what would you do? And that's sort of like the gap we're trying to fill. So if you're able to use the GPUs, at least for OCF, if you're able to use the GPUs either on Summit or Frontier, and your science use case matches interest of the OE, which are fairly wide, we have projects in many scientific domains. I'll be happy to, like, if you submit the Pathways to Supercomputing Initiative interest form, we'd be happy to like go over it and set up a call to like try to figure out, like, okay, is your workload actually need leadership computing resources? Because if maybe the project you have in mind is actually sort of finite, like you have 10 samples and that's all you're going to run, then maybe not, because you could run that elsewhere. But if something that you're like, this is how I started, this is what I have, but if I had all the computing in the world, I would run 20 million samples or something like that. That's sort of where we're trying to find out, like, if you had more resources, what would you do? And if the answer to that is still uses the GPU, I think that's a very good case to submit a proposal and try to help you get the workload and the data you need. Because once you have access to the machine, what you would need for one of the other allocation programs is to have a scaling data to show, like, yes, this is what I'm doing today, but this is what I plan to do in the future. And here are numbers to show that, yes, my code takes advantage of the GPU. And yes, I know what I'm doing. And this is the science that I want to do, to kind of put it very clearly so that when you submit a bigger proposal, because the worst thing that I don't want to happen is people put all this effort and then they get rejected, because we're trying to help bridge the gap. And that's what for the Pathways to Supercomputing initiative, we set up sort of a call to understand what is the person trying to do, does it actually fit? There are other resources available that are maybe non-DOE that people could take advantage of. So we try to, obviously I care about DOE resources first, but if there's not a use case for DOE leadership computing facilities, perhaps it could be some NSF resources are open to researchers that you can partner with. Things like Chameleon Cloud that we've had used before for some webinars, because like I mentioned, there are a couple of restrictions. There are a few countries that cannot access DOE resources because that's how the specific restrictions US government imposed. But in previous trainings we've done, we have actually partnered with Chameleon Cloud and other resources that are open to anybody. And that way we can still enable the science, even though maybe people are not running on our system specifically, because the whole goal of the collaboration is to help bridge the gap wherever we can. It's not necessarily to bring people to DOE, but if the case is well suited for DOE, we definitely want you to apply.
Wonderful, thank you. And can you expand a little bit more on how or what someone would need if, let's say, they're coming from a Latin American country or maybe another country abroad, and they want to gain access to US-based resources? I think you had mentioned to me in a prior call that they would just have to have collaborators that are also based in the US. Can you expand a little bit more on that criteria, or what you would look for specifically for a project that's coming from another country, what it would take for them to be able to qualify, essentially?
Well, for the DOE programs, you don't have to have a partner in the US. We've been trying to partner people just because we've seen that it helps. That way they can, because maybe somebody like Sylvia, who is part of America's HPC Collaboration, is more familiar with what kind of proposals Argonne receives and knows what kind of information Argonne would like to see. So he can sort of mentor the person, but you don't necessarily have to have a partner. Like we have users from all over the world that they just submit their proposal and they get reviewed like everyone else. So there is no restriction in that regard. For some of the other programs, like for NSF, for example, I think Chameleon Cloud, and NSF is the National Science Foundation, in case others are outside the US listening to this, they do have some restrictions. A lot of the NSF funding cannot be used for external, but you can be a partner with someone. So if somebody is, say, working on molecular dynamics, and they're studying the particular thing you're studying, and we make that connection, and you have an actual interest in collaborating with a researcher, you can join their project after they already have an allocation. And that way we've seen like collaborations like the one that I highlighted here was with Argonne, but we've seen collaborations with other institutions besides Argonne that are working with centers like TAC or other NSF centers. And they partnered with somebody that was a PI in the US to apply for resources that way. But for DOE resources, that's not a requirement.
Great, thank you for clarifying that. We do have another question in the chat that says from Eduardo Ulysses, hello, great talk. Could you talk a little bit more about the energy consumption of these machines? And what is your opinion that only Brazil and Argentina machines are in the top 500 this year? So two separate questions.
Sure. So, I mean, I think Frontier itself, like the power consumption right now, I think if in a normal day is probably about 15 or so, maybe 15 to 20 megawatts, but the machine is always full. When we run HPL, it exceeded 25 megawatts of power. So it does consume a lot of energy. And that's one reason that scaling beyond Frontier is also challenging, because if we wanted to have a bigger machine, like power is definitely top of mind, and it's something that we're trying to do, and getting more codes and more workloads to move to efficient chips like GPUs that are on Frontier, because Frontier is also in high up in the green 500 because it's a very efficient machine. The number of flops it can give per watt is way more than what we had before. So as efficient as it is, because of its scale, it's still the power that it takes is fairly large so it's very hard for a lot of facilities to have a machine of this size or even bigger than this. But it's definitely coming to a point where it's like prohibitive to have a machine that will be much, much larger than Frontier, like Summit versus Frontier. Like Summit was 200 petaflops, Frontier obviously broke the exascale barrier because we talked about it a lot when it happened. But if we wanted to go like to the next level, like that would consume a lot of power with current generation of architectures. But I think now the focus is slightly shifting into how do we focus on making codes or like making workloads that actually use the least amount of energy possible and still get you the results that you want. And there's a lot of interesting approaches that people are discussing, and hopefully in our next system that those will be reflected. And as far as what is my opinion on why only Brazil and Argentina machines are in top 500? I mean, I see top 500 as something like useful for, I guess, to demonstrate that the machines exist, but not necessarily as a requirement for it to be like, if your center is not there, it does not mean that you don't matter. Like there's like a lot of supercomputers that are available out there that I learned when I started going to Carla, but I don't think that it's necessarily what you want to strive for is to be in top 500. I think what you want to strive for is to be able to show what science you can do with your machine, or with partnerships that you form that gave you access to other machines. I know that there's many more systems in Latin America than what is shown there. And a while back, there used to be a top 50 in Latin America that I'm not really sure who started, but it was cool to see, just to see which countries had an HPC machine. But being a resource, like to run an HPL number, you have to consume resources. And those resources are not necessarily producing science, you're just getting a number. I think it's probably less important to submit a number than to show what your machine can do with real science.
Great, thank you. And there's been a lot of interest lately from the AI community, at least a subset that's also working on quantum computing. Are any of the machines available from the Oak Ridge National Laboratory or Department of Energy or within the broader HPC collaboration network that you know of that is capable of also running quantum experiments?
So we do have at least at OLCF, we do have a quantum user program where you can similarly apply to get time. The machines are not hosted here. Like we partner with several vendors so if your project is accepted, you get cycles in one of the vendors because we don't have our in-house quantum computer. But there are programs currently available through the Quantum Science Center, and I can put the link in chat. And that's one way that we've been getting folks, projects from folks with fulfilling the need there. But one of the things that we are doing on our machines, like our HPC machines, there's a lot of work that I think several companies have been doing, but NVIDIA released like Q-Quantum and CUDA Quantum to do like modeling of quantum devices and other similar projects that have come up. And we're providing those on Summit so that people that have quantum related projects but are not running on a quantum computer yet, they can do the simulations there.
Great, thank you. And what is the most interesting project that you have seen come through your lab so far from these applications? Is there like a very unique one that stands out?
Through like the pathways to supercomputing or just in general?
Either actually would be fine to answer.
One of the recent projects actually, it was a partnership with industry. The folks were running in on Frontier, like folks from GE were running, and they did simulations to understand turbulence, and they actually improved the efficiency of their engines by doing simulations that they couldn't do before Frontier existed. And they've been one of our like they've used the machine a lot. Like they probably have a lot of high utilization on the machine if you look at number of jobs. and they were doing science that couldn't be possible before, and that science realized into actually more efficient engines that they're using in the future when they're building their engines. And seeing that is sort of like what keeps me in HPC, because you actually see the impact of, yes, you see a lot of people running jobs, but you can also see how that translates to real life. And similarly, before, like maybe 3 years ago, when pandemic happened, Summit was used to screen potential drug compounds that could help, and being able to quickly do, okay, this is what we're going to do, and helping, because rather than somebody sitting there trying to do experiments as fast as they could, the screening helped them at least narrow down to start, okay, let me start in this area versus start from 1 through a million. Like you can start, oh, I'm going to pick this ones first and see what happens, and just being able to help as an instrument of science versus it's just sitting there running, I don't know what you could run, Bitcoin mining. Like I think that part is what makes me stay in HPC, because our machines are being used for good, to put it in, I guess, a short way. They're being used for good.
Thank you. And then you mentioned several opportunities for people to volunteer and get involved with the HPC collaboration. I see you've also posted that Slack channel, so just as a reminder of those that are joining us, that if you'd like to get involved with the Americas HPC Collaboration, to join the Slack and find opportunities. Can you review again for those opportunities in particular? I know you talked a lot about mentorship or helping out, with some of the admin aspects, hosting events, and so on. Where's the most need from your community organization for people to get involved?
I think for America's HPC Collaboration, we would really love to hear from people's research, like what are they doing today? And if they want to give a seminar on what they're doing, and maybe what are the blockers that they see, like if somebody has applied and maybe didn't get it, or if somebody is interested in apply but is concerned about what it is. Like that's one area that we've been trying to kind of understand a little better, like what is keeping people from applying and how we can help remove that barrier, whatever that barrier may be. So, but if people have any kind of research that you're doing today in HPC or AI or combination of both, we'll be happy to host you as a webinar. And if you are more interested in like helping behind the scenes, we'll love to have somebody help keep our website updated, and maybe coordinate events, organize the events, set up the Zooms and all that, because I think the more people are involved, the community will flourish, because there's a lot of going on and a lot of initiatives, and being able to document everything that's been happening would be also super helpful.
Great. And maybe as our last question, we know we have a lot of community members who are looking for new opportunities for employment. Maybe they're interested in working at a company like Oak Ridge National Laboratory with the Department of Energy. And you talked a little bit about your background and how you got to the point where you are today. Could you give some advice to others that maybe come from a more traditional computer science background or a more specific artificial intelligence background? Are there opportunities available for them to work at a laboratory like yours? What would your company look for as far as new hires? Are there specific openings that you think would be beneficial for them to apply to? And then what they can do essentially to kind of boost up their CVs and resumes, or their extracurricular activities, to make them a really an appealing candidate for hiring.
Yeah, we have a lot of job openings, particularly in the new like emerging areas like AI and quantum, because those are areas that are growing rapidly. And depending on what part of this house you sit in, like I'm in a technical track, but I also work a little bit on research topics. But there's folks that are primarily in the research track, and they spend all day, every day working on research. So depending on what side of the house you sit in, being able to demonstrate like your expertise, if you're a researcher, and like with papers that you're submitting, or like collaborating, providing service to conferences that you participate in, getting your name out there in publications is definitely key. But then the other piece that I always forget to mention, but working in Oak Ridge National Lab, we allow foreigners to work here. Like a lot of the times people see DOE, like US government, probably you have to be a citizen to work here. Majority of people that work in research here are not from US. I mean, that's probably exaggeration, but there's a lot of folks that are coming from abroad. And I think, especially in the research area, because it's a lot more niche and it's something to have if you're highlighting a specific area, like if you're focusing on large language models, that's super popular right now. And if you're in the research side, we hire a lot of postdocs. If you're still a student, we hire interns that are working here in the lab throughout the year, part-time, and some in the summer, they come full-time here. And if you already graduated, we have researcher positions, but we also have technical track positions. Like, for example, in my group, we hire folks that may already have PhDs or not, but depending on what their interest and what their expertise is, they'll help users and scientists and researchers run their workloads on the machine, identify problems, come up with tests. So there's definitely a little bit of everything. Like the lab has about 6,000 people currently, and it's a mixture of researcher and technical track and support staff. But we look for backgrounds, diverse backgrounds, and we want to make sure that we fill the need. But particularly if you're focusing on the research side, I would say look for a specific researcher that you've read papers for, or group that you know works in similar field as you work on. And if you want to reach out to us, and same for Argonne, because I know if Silvio was here, he would say the same. If you find a researcher, you're like, oh, I think their research overlaps a lot with mine. I'm happy to like send them a message, or if I know them, be like, oh, make an introduction. Because I think that's sort of one of the things that helps reduce the gap is if you are able to at least have a conversation. Like you were like, oh, we work on the same thing. Maybe I can help you connect so that you guys could start your own partnership, or things like that are something that at least helped me. Like when I moved to Oak Ridge National Lab, I didn't even know I could work here to begin with, but I only found out because I was helping at a conference committee for SC 13, and I met my current boss today. And it was just through networking that I found out that was the case, that you could work here and that my skills were useful and that I should apply, and I did. But otherwise, I wouldn't have known. So I think if you're interested, reach out, join our community in Slack. We sometimes post jobs there. We sometimes you can ping us directly and say, hey, I saw this job at Oak Ridge or Argonne. And I think it will be the easiest way to go.
Great. And then one final quick question, because we also have a subset of our community who's interested in using AI to create companies, right, and have startups. Do you know if the Department of Energy or Oak Ridge or any of these other organizations have opportunities or support new businesses or startups that are also maybe in high demand of computational power?
We do actually have, and that's something I should add to my normal status, like industry partner program. So that's how like GE ended up using Frontier. We have an industry office that they basically go out there and see like, oh, who needs compute, and try to figure out if our machines are good for what they're trying to do. Similar like I do with like research side or technical side, they focus on industry, and I'm happy to share their info with anyone interested.
Great. And how should someone reach out to you? Are you comfortable with us sharing your LinkedIn profile or your email, or what's the best way for anyone to contact you?
I think LinkedIn is usually the easiest, but also in the Slack community, we usually try to keep that also in the top of mind, because we're trying to organize events for 2024. So many of us are looking at that. But yeah, I think you posted already. But yeah, my LinkedIn is probably the easiest way to reach out.
Wonderful. Thank you again so much, Veronica, for your time today and for sharing these amazing opportunities with our community. It is very exciting to see what others are currently doing and how essentially someone can grow and scale their machine learning models utilizing these additional compute systems and resources, whether they're located here in the US or, of course, in other countries from within our network. So we, of course, will be in touch. And also thank you for sharing information about our organization with your communities as well, with the HPC collaborations, and then with the Department of Energy in Oak Ridge. We want to thank everyone who was able to join us today. And so for those that are learning about our organization for the first time, again, we are the Latinx and AI organization and programs. Essentially, we offer many different opportunities for those who are working within the artificial intelligence field to essentially grow their career, and that could include engineering, research, business development, startups. Our programs focus around, for example, hosting research workshops where we allow opportunities for representation for our members to share their work, to gain insight, to collaborate. We also have some grant-making programs where we do cover things like cost of travel, per diem registration, and so on for attending different sessions at conferences in order to publish your work. We do have our Journal of Latinx and AI research program, and we, of course, we do also have our supercomputer program, which has now provided hardware computational infrastructure to a university research institution at Tec de Monterrey in collaboration with NVIDIA and the Digital Agency for Innovation for Guadalajara. So those are some of our programs, as well as a mentorship program for research as well, and for startup business development within the artificial intelligence space. If you have any questions or would like to learn more about our community, please join us at www.latinxandai.org, and we will be hoping to host more of these sessions, in particular around high computational power machines and supercomputers around the world, and projects that are utilizing them as well from our organization and from our membership base. So thanks everyone for your time. That's all the time we have today, and we look forward to connecting with you again soon.
Thank you so much, and thank you for the invitation.